Hello, future engineers, subscribers, viewers, and students. There is another video in differential calculus, particularly about mastering equations of tangents. And from there, we can master sketching of curves. So this is about slope of curves and tangents. There are 5 exercises here. So the first problem in part A, for the function g, whose graph is given, arrange the following numbers in increasing order and explain your reasoning. So the graph is here, and let's estimate the slope for the function value from the given curve. So that should be our guide so that we can arrange the values here in order, increasing order. So this is the graph, and these are the values. So we have function value, or the value of g when x is 0, f of g of 0 also is 0. So 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. Let's arrange them in increasing order. So we estimate the slope of the tangent at -2, and we will call that g prime of -2. And from there, that slope is, in my estimate, about 2 or 2 something. So g prime of -2 is 2, or the slope of the tangent on the curve at g is 2, g is -2 is about 2. Then we estimate g prime of 0, which is the slope of tangent here, and that is about less than, that's a negative slope. So in my estimate, I just present it as -1.5. So g prime of 0 is about -1.5. And we also have g prime of 2 here, the tangent at 2. So that's the tangent line at 2, so that's around +1. That's a positive slope, so g prime of 2 is 1, in my estimate. Finally, g prime of 4 here, into a tangent line to x is 4. And in my estimate, that is about 1/2. G prime of 4 is 1/2, or 0.5. So therefore, we can now arrange these values in order, increasing order. So there's a negative value, which is -1.5. So that should be the first. Then after -1.5, there's only one -1.5 in the representation, and therefore the next value will be 0. So -1.5, g prime of 0 first, because it is -1.5. Next is 0. Then next is g prime of 4, which is 1/2, +1/2. Then after g prime of 4 is g prime of 2, because it's 1. The maximum value in these numbers, in this function value, is g prime of -2. So next is g prime of 2, which is just about 1. So g prime of 4 is about 1/2, so g prime of 2 is about 1. And finally, the maximum value in these values is g prime of -2. So therefore, that's the arrangement, and that's our answer. For part B, if the tangent line to y equals f of x at 4, 3 passes through the point 0, 2, find f of 4 and f prime of 4. Take note that 4, 3 is also a point on the curve or on the function, and it is the point of tangent C. Therefore, f of 4 is equal to 3. That's already given in the problem. While f prime of 4 represents the slope of the tangent when x is 4. So let's derive the formula for the slope of the tangent to the curve. The slope of the tangent to the curve is simply the slope of the line between these 2 points. This is the point of tangent C, and the tangent line passes through that point. So that's the slope of the line joining these 2 points is the slope of the tangent, and it is f prime of x. F prime of x, or dy dx, or slope, is 3 minus 2 over 4 minus 0. So that's also f prime of x. 3 minus 2 over 4 minus 0, so it is 1/4. Therefore, f prime of 4, which is us, is equal to 1/4. Part C is sketch the graph of a function for which f of 0 is 0. So let's have the coordinate plane. So this vertical axis is the y-axis, positive upward, x-axis horizontal to the left, to the right. So we have 0, 0 as a point. And at this point, let's draw the tangent represented by black line, which is slope, because f prime of 0 is f prime of, let's get the graph. F of 0 is 0, which is this. F prime of 0 is 3, as shown. So this tangent at x equals 0, f prime of 0. So slope f prime when x is 0, and that is equal to, this is the line, and that's about 3 units upward and 1 unit to the right. That's it. Next is f prime of 1, 0. The tangent when x is 1 here is 0, or horizontal, as shown. So it may be anywhere, but definitely above 1. Then f prime of 2 is -1, so it is a line that is sloping up. So may not be here, up to the left, and the slope is -1. So let us say this is the point 2, the slope of the tangent, is the representation -1. So that's correct, approximately. And finally, f prime of 2 is -1. So that's already the graph. So we draw tangents to these 3, and infinity it is going down, and tangent when x is 1, like that, passes through this point. Point of tangency is more than 1, shown. So it is represented by this red curve. So that is y equals f of x. D is the same as C. So we have h of 0 equals 0, so it also passes this point. The slope h prime of 0 is 3, so it's the same. This black here passes to that point. Then h prime of 1 is 0, so almost the same as this. And finally, it's h prime of 2 is 1. So we only have one. So this is not included anymore. When x is 2, the slope is 1, so it is up to the right, as shown by this blue line. So to connect these tangents, this 1, second, then third, so it should be a graph like this. Tangent to this, then same, but going down. And that is denoted by this blue curve. So this is h This is y equals h of x. Then finally, letter E, if h of x equals 3x squared minus 5, find h prime of 2 and use it to find the equation of the tangent line to the parabola 3x squared minus 5x at a point where x is at the point 2, 2. So when x is 2, 3 times 2 squared minus 5 times 2, that's also 2. So that's correct. That's a point of tangency. So we derive h prime of x, which is simply the derivative of h of x, and that is 6x minus 5. Since the point of tangency is when x is 2, so h prime of 2 is 6 times 2 minus 5, that is 7. So h prime of 2 is 7, and therefore h prime of x is 7. In general, 6x minus 2, but to find the equation, so h prime of 2 is 7, that's our answer. Then when x is 2, y is 2. The expected equation of the tangent is, because the slope is 7, 7 minus x equals 7x1 minus y1. So 7x minus y equals 7 times 2 minus 2. So that's the expected equation. Then expressing y in terms of x, transpose to the right, y equals 7x minus this value, which is 14 minus 2, 12. So y equals 7x minus 12. So that's it for this video.